Okay guys, what we're going to look at now is equations that are in the form of x to the power of n equals a. So for example, we could have x squared equals 16. Okay, we could have x cubed equals 8. All right, things like this. Now, what we want you to do now is we want you to shift a little bit away from always trying to move everything to the left and solve. If you have a situation like x squared equals 16, we want you to think about what that means in terms of looking at the graphs. Okay, so thinking about what we did last lesson, if we look at x squared equals 16, we know that what we have is, looking at our coordinate plane, this is our x-axis, this is our y-axis. Okay, so we have an equation for x squared. Okay, so look at that as something like this. This is what x squared looks like. Okay, now if we have x squared equals 16, then we know that our second equation that we're looking at is y equals 16. Okay, so what we have here is we have a function across here. This is y equals 16, and this is y equals x squared. And we're looking at the intersection of these two graphs. Okay, that's what we're trying to solve. What are these two intersection points? Okay. Now, yeah, this seems pretty easy. Okay, but what we want you to do today is try and come up with some of the patterns that you're going to need for this. All right, so in this case, we know that we have x squared equals 16, x equals the square root of 16, or x equals the negative square root of 16. Please don't forget the negatives, and you should now be able to see that by looking at the graph. Okay, you can see that we clearly are going to have two solutions here. All right, now this x cubed equals 8. I'll just delete it. We'll go down a little bit further to look at that one. Okay, so x cubed equals 8. Now think again about what the graph of x cubed looks like. Okay, so let's just draw a quick sketch. As usual, it doesn't need to be anything perfect. Okay, sketches are just a rough drawing. Okay, so we know that the graph of x cubed, as we go from left to right, it's increasing. Okay, so we have a graph that looks like this. Okay, this is y equals x cubed. All right, now we know that we have for y equals 8 just a horizontal line, y equals 8. And you should be able to see here that this time with our intersections, we only get one intersection point. Okay, so we know that x equals the cube root of 8, which equals 2. Okay. Let's look at a couple more. All right, obviously this pattern holds for x to the power of 4, etc. as well. So let's have a quick look at that, because you do need to realize that it does mean we're going to have a different result on our calculator. So if we have x to the power of 4 is equal to, I don't know, let's go 64. Okay. All right, we know what x to the power of 4 looks like. Okay, it is, maybe I might try and do the sketches on this side. We can have the calculations on the left. All right, so we know that we get a graph that looks like this. It's a bit squarer at the bottom than the x squared. So this is y equals x to the 4. Okay, we have a line, a horizontal line at y equals 64. And what we're looking at are the intersection points on those. Sorry, just labeling my axes. Okay, so we have this intersection point here and this intersection point here. So you can see with x to the power of 4, we still have two solutions. Okay, so we get x is equal to the 4th root of 64, or x is equal to the negative 4th root of 64. Okay, now if you do that on your calculator, you will see One moment. Fourth root. Okay, you need to use shift for that one. Okay, and it's going to give us an approximation. So you will get x is equal to, or it's approximately equal to 2.82, or x is approximately equal to negative 2.82. Okay. Now this pattern continues. What you need to think about though is that we've always said in the past, if your line is below the if your horizontal line, so the red line, if that's below the vertex, then you don't have a solution. So we need to think about that as well. Now let's make a little scheme for this, just like we did with the last lesson. Okay, so we have a box like this. Okay, and this time we have x to the power of n equals a. All right. Now we can have n is even or n is odd. Okay, and remember, if n is even, that means our shape looks something like this. If n is odd, that means our function looks something like this. Okay, we can have a is positive, so greater than 0. We can have a is, wow, I don't know what I'm doing right now, a equals 0, and we can have a is negative. Okay, now thinking about it, for n is even, if a is positive, that means that that red line is going to be above the x-axis. So if a is positive and n is even, we will always have two solutions. Okay, you'll get a positive and you'll get a negative. Those are your two options. Okay, if a is equal to 0, so if our red line here was on the x-axis, then we would have one solution. Okay, and if a is negative, that means it's below the x-axis here, which means the two lines don't ever intersect. So that means we have 0 solutions. Okay, and when I say one solution here, the answer is just that x equals 0. Okay, now if n is odd, okay, so if we have one of those cubic equations and a is greater than 0, you should be able to see that that's going to mean that that red line is above the x-axis. That will give us one solution. Okay, so one solution. Okay, and that's going to be a positive solution. Okay, if a is 0, it's going to be on the x-axis, which again is going to be one solution. Okay, and that again is going to be x equals 0. Now, if a is less than 0, in the case of a cubic equation or a x to the power of 5 or x to the power of 1, just x, y equals x, you will see that your solution, there will still be one solution. Okay, so it doesn't actually matter where we move this red line. If I move this red line down here somewhere, okay, there's still one solution. All right, anywhere that I put it, there will always be one solution. So you should be able to see that with a uneven power, okay, if n is odd, we always get one solution. In this case, it's going to be negative. All right, so you will see sometimes that you will have a negative answer with a cubic equation, for example. So for example, if we had a to the power of 3 equals negative 1. Okay, this is a nice one. Sorry, why did I say a? I don't know. Let's make it x. All right, so x cubed is negative 1. So let's have a quick look at what the sketch would look like. Okay, here's our lovely coordinate plane, X and Y. Okay, we have a graph that looks, that's a horrendous axis. Let's draw it again so it looks a bit nicer. Okay, it is a sketch, but it should at least be a little close to normal. Okay, that's better. X and Y. Okay, our graph x cubed looks like this. This is y equals x cubed. Okay, and our graph for -1 is just a line over here. Y equals -1. Okay, you can see the intersection point is here. Okay, and there's one of them. If you do that on your calculator, x equals the cube root of -1, which is equal to -1. And if you think about it, obviously that's going to be the answer, because -1 times -1 is 1, multiplied by -1 again gives you -1. Okay, so that's it. Basically for this topic, sometimes you're just going to have to make sure you can isolate that the x, okay, the x cubed, x squared, whatever. Okay, that should always be your first step. So isolate your power function so that it's x squared equals or x cubed equals, okay, and then solve it later. When you get up to question 45, you'll need to be a bit more careful, okay, because there'll be an extra step you need to do at the end. So for 45, do not expand the brackets, okay, for most of them you can't anyway. Solve it as you would here, but then remember that you would have x plus something equals this. Okay, so there's an extra step to do at the end. All right.